Hi, and welcome to this two-part Solidworks tutorial. In this video, we will be creating the first part of a space-themed wooden bead maze toy. You will be able to download the decals and the DXF files I am using in this tutorial from the description below. You could also design your own in a vector-based program or use imagery from the internet. To begin, click New and Part. Starting with the base, I extrude a 200mm circle to 12mm thick on the top plane. Then fillet the top and bottom faces by 1mm. Now I'm going to start a sketch onto the top face of the extrusion. Using the centre square tool, I give myself 4 equal guide points. I then select the whole sketch and tick the full construction box, as I only want to use this sketch as a guide. Using the guide sketch, I draw 4 equal circles. I then want to extrude these to 3mm, unticking the merge result as I want these parts to be separate. I then want to chamfer each edge by 2mm at a 50-degree angle. I do this to all parts. I now want to import the DXF file for the sun, which will go in the centre of my bead maze. To do this, we click on the plane that we want to import the DXF onto. We then click Insert, DXF. From here, you want to select the DXF file and click Open. A dialog box will appear here. You then want to click on the next button, where you will see a preview of your DXF in the black box. Using the drop-down menu, you need to select the units in which you want to import your DXF file. This will depend on what you exported your DXF file in. For me, I always use millimeters, so I just click that. I can then click Finish. The DXF will then come in as a sketch, which you can then move entities into place. From here, I extrude the sketch mid-plane so that it remains center of my model. I then untick Merge Result so that it remains a separate body. Now I'm going to cut the holes into the maze stoppers, ready for the wires. Sketching onto the top face of the stoppers, draw 4mm circles for the thickness of the maze wires. Make sure to tick Cut through all bodies, as the wires will need to go through the base too. Now we are ready to start on the wires. I will begin with the largest loop. For this, I need to add a new plane that crosses through 2 diagonal stoppers. To add a new plane, click onto your front plane, then Reference Geometry up on the top bar, Plane, and the options box will appear on the left. Here you will need a second reference. This should be your right plane, which I can select from the Features tree. I then tick Flip Offset and click on the green tick. Using our new plane, we will start the guides for our wires. So take the centerline sketch tool and draw from the midpoint of each extruded circle up in a vertical line at 120mm each. These are our starting points. Now I need to prepare my model for a helix. To do this, I need a new plane, spaced 30mm away from our plane 2. We need to draw a circle guide for our helix. I center my sketch between my previous sketches with a 205mm vertical center line. Using the center line, I draw a 140mm circle. I can now create a helix. You can start the helix with your circle sketch open or closed. I just prefer to close it. In the Features toolbar, select the Curves drop-down menu and select Helix and Spiral, then select the circle sketch we just made. The tool options appear on the left, and a preview of your helix becomes visible. Change the height of the helix to 60mm and reverse the direction so the helix becomes center to the model. Change the start angle to 90 degrees and the revolutions to 1, keeping the helix running clockwise so that it starts and ends at the top. Click the green tick to finish. I now need to connect my sketches up, so here I use the 3D sketch tool found in the sketch drop down menu, selecting the spline tool I join up my helix to the adjacent centre lines. I then need to play around with the splines to create a smooth wire path. Click on the points at the end of the splines to use the spline handles. Use these to drag the spline into place. You will also need to input the angle of the point in the left side menu. For the bottom angle, I put 0 degrees and minus 90 degrees for the top angle. This ensures our spline begins vertical. Now do the same for the other spline. Looking from the top of the model, I can see that the spline sketch doesn't line up with the helix. So again, with the spline handles, drag and pull the spline until you are happy with the path. Do this for both sides. Once I am happy with the sketch, I convert both lines to construction lines. We now have a path guide in which to create a continuous 3D sketch. Select 3D sketch from the drop-down menu and use the spline tool to trace over your guide path. Keep this spline continuous. It doesn't matter how many points you add around the curve, this will just make your path more accurate. Once your spline is finished, straighten out the start and end splines using the handles and inputting the angles in the options menu. By dragging the spline handles down and making them shorter, you make the spline straighter. Do this for both sides. Look at the model from different views to make sure the splines are straight from all angles. To make my 3D sketch easier to use, I am hiding the guide sketches. I now want to create a sweep along my path. To do this, we need to create the profile. Sketching onto the face of the cut extrusion, I convert the entities, creating a 4mm circle. We can now go to the Features toolbar and select Sweep. You need to select your profile and then the path. And because I want the sweep to be a separate body, you need to untick the Merge Result box. You then click the green arrow to confirm the feature. Moving on to the second bead wire, I will hide these planes and create a new plane, the same as before, by selecting the front plane, reference geometry, plane, and using the right plane as my second reference so that it centers through the two other maze ends. Same as before, we need to sketch our guides from the centre of each cut extrusion. This time, the left sketch is 40mm and the right sketch is 75mm. Now we need a helix. Selecting the face of the base extrusion, reference geometry, and new plane, position the new plane 55mm above it. On my new plane, I draw a 130mm circle ready for the helix. As before, select Curves on the Features toolbar, Helix and Spiral, and the Options box will appear. For this helix, I want it to be 40mm in height, 1.25 revolutions, and a start angle of 180 degrees. These points will then need joining with the 3D sketch. Using the 3D sketch tool and the spline, I join up the helix to the guides. Like before, the splines need manipulating into place to create the right curves for the maze wire. The best method for this is to use the spline handles to drag into place and then manually input the angles for the spline point. To match the vertical guideline path below, I put 0 degrees for the bottom angle and minus 90 degrees for the top. I do the same for the other side. The next spline handle is done by eye. Viewing the spline handle from several angles, the top view shows the path running in a smooth spiral. Once I'm happy with the sketch, I convert the splines for construction. Using the 3D Sketch Spline tool, I need to trace over the guide sketches as I did with my previous maze path. The more points I add along the curve, the more accurate the trace will be. When you reach the straight guide sketches, only click the spline to the top and the bottom points. This makes it easier to manipulate afterwards. Once your spline is finished, straighten out the start and end splines using the handles and inputting the angles in the options menu. Once more, create a sketch onto the cut extrude face, convert entities, and open the sweep feature. This time, I have left my guide sketches visible. By doing this, you can select the wrong path as highlighted here. So I select the orange path that you can see runs from start to finish. Select the path. Unmerge the result and confirm the feature. With this component of the bead maze complete, I just need to add the appearances and decals. Using the solid bodies drop-down menu in the feature tree, I select the bodies that I want to add an appearance to. Starting with the base, I click onto Edit Appearance on the right side toolbar and select Polished Ash. I change the mapping of the appearance to projected and shrink the wood grain to look like a piece of plywood. The top of the base doesn't look right, but I'm going to add a decal here. Selecting the face and the Edit Decal icon here, I can browse for my decals. I create my decals in vector software and export them as JPEGs. Useful tip: ensure decals are exported in RGB over CMYK. You can do this in your colour settings. This will give you the most accurate colours in your renderings. Selecting my decal, it automatically fits to size, but if you go into mapping, ensure it is fit to width and height by clicking in the boxes. Next, I select the large sweep and select Edit Appearance. Here, I want to use medium gloss plastic. If you want more colour options, double click into the white eyedropper box. Here, you can manually input the exact colour you need. I want it to match the base, so just type the values into the RGB boxes and select OK. For the second sweep, I want to keep it a medium white gloss plastic. I want to make all the maze ends glossy rubber, just like the real toy. Finally, I need to add the decals to the sun. Starting with the main colour of the body, I project the decal, ensuring it covers the whole sun by dragging on the decal window. Then, selecting the face of the sun and Edit Decal, I can add the face artwork. However, this time I want the decal to be on two faces. To do this, click on Mapping and in the drop-down menu, select Projection. Click into the selected geometry box and select the back face of the sun, ensuring the decal covers the body fully. Now our model is ready for the second video segment, where I will show you how to create parts to add to the bead maze in a fun interactive assembly. Thank you for watching.